Today we will be doing another type of bond known as the covalent bond. In the last class we had done electrovalent bond, and an electrovalent bond is formed between a metal and a non-metal. A covalent bond is formed between two non-metals. That means when a non-metal reacts with another non-metal, a covalent bond is formed. In an electrovalent bond, let me write it down. In an electrovalent bond, we had a metal reacting with a non-metal. The metal gives electrons, whereas the non-metal receives electrons. Metals, after giving electrons, gain positive charge, and non-metals, after receiving electrons, gain a negative charge. And ions are formed. Cations and anions are formed. Whereas in a covalent bond, there is no such thing as giving and receiving of electrons, because it is the reaction between two non-metals. So let's see how a covalent bond is formed. So the first one is formation of a hydrogen molecule. Now H is an atom of hydrogen and H2 is a molecule of hydrogen. So this is an atom of hydrogen and this is a molecule of hydrogen. So we have to show how a hydrogen atom forms a molecule of hydrogen. Here what is the number? 2. That means two hydrogen atoms react to form a molecule of hydrogen. So what happens? Two hydrogen atoms react to form a molecule of hydrogen. So what is the atomic number of hydrogen? It is number 1 in the periodic table. That means atomic number of hydrogen is 1. We know atomic number equals to number of protons, which is equal to the number of electrons. So if atomic number is 1, number of protons is also 1, number of electrons is also 1. Now we write the electronic configuration. So how many hydrogen atoms do we need to form a molecule of hydrogen? 2. So 2 hydrogen atoms. Since only 1 electron, so the first orbit will have only 1 electron, and here also the first orbit will have 1 electron. So atom of hydrogen, this is another atom of hydrogen. In the nucleus we have the protons, number of protons 1, number of protons 1. So 1 electron here and 1 electron here. Oh, it looks like the same color. So let me use black. The orange and pink are looking similar. Black. Okay. Now suppose if this gives away electrons, then this atom only will vanish. And if this atom gives away electrons, then this atom will also vanish. So there is no question of giving and taking, and both are non-metals. We know only metals give away electrons. So what happens in a covalent bond is they share the electrons. So that there is no give and take. There is sharing of electrons. So when they share electrons, this atom will have how many electrons? 1, 2. And this one will also have how many? 1, 2. So let's draw it. So there is no giving and taking, but what did I say? They share electrons. So now this atom will also have 2 electrons. This atom will also have 2 electrons, and we know that the first orbit has 2 electrons. So this becomes, so when these two combine, so how many electrons did they share? 1 electron each. So this hydrogen atom shares 1 electron with this hydrogen atom to form a molecule of hydrogen. And since they're sharing only 1 electron, this type of bond or this type of covalent bond is known as single bond. See here once more, we had to show the formation of a hydrogen molecule. H is atom of hydrogen, H2 is a molecule of hydrogen. That means we need 2 hydrogen atoms to form a molecule of hydrogen. Periodic table number 1, hydrogen. So the atomic number of hydrogen is 1. Atomic number equals to number of protons, which is equal to number of electrons. So if atomic number is 1, number of protons is also 1, number of electrons is also 1. Using this electron, we write the electronic configuration. So since only 1 electron, so H equals first orbit, 1 electron each. Now we draw the 2 atoms of hydrogen. Since hydrogen is a non-metal, they do not form a electrovalent bond. I have told you covalent bond is formed by 2 non-metals. So non-metal, non-metal. So no give and take, but they share electrons. So here we show the 2 atoms sharing electrons, hence forming a molecule of hydrogen. So one hydrogen atom shares this is one hydrogen atom and this is the other hydrogen atom. They share 1 electron, forming a hydrogen molecule, and this type of bond is known as a single bond. Now you may be thinking that no, they are sharing 2 electrons. They are not sharing 2 electrons. This is sharing 1. This is also sharing 1. See, how many bonds have I formed? Only 1. So this bond is known as a single bond. Let's go to the next example. Number 2. Formation of an oxygen molecule. O is an atom of oxygen. O2 is a molecule of oxygen. Now, you may be thinking why O2 is a molecule. Remember, we had done a monoatomic, diatomic, triatomic, and polyatomic elements. So hydrogen, oxygen, nitrogen are diatomic. They are found always in the diatomic state. That means 2 atoms combining together to form a molecule. So O plus O will give you O2. That means we need 2 oxygen atoms to form the molecule of oxygen, 2O2. That means 2 atoms. Atomic number of oxygen according to the periodic table is 8. So we know atomic number equals to number of protons, which is equal to the number of electrons. So if atomic number is 8, number of protons is also 8, number of electrons is also 8. So now we write the electronic configuration. Number of electrons is 8. And we have 2 oxygen atoms. First orbit, 2. So 8 minus 2 equals to 6. So 6 in the second orbit. Same thing here, first orbit 2 and in the second orbit 6. First orbit can hold a maximum of only 2 electrons, and from the second orbit onwards it is a maximum of 8 electrons. P equals to 8, number of protons equals to 8, number of protons equals to 8. So first orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6. Here also same thing, 1, 2, 1, 2, 3, 4, 5, 6. Now we know from the second orbit onwards there should be 8 electrons. For the atom to be stable, there should be 8 electrons from the second orbit onwards. In case of hydrogen, it was only the first orbit. That is why we took 2 electrons. Whereas here in oxygen, in the second orbit, we need 8 electrons. So 1, 2, 3, 4, 5, 6. That means I need 2 more electrons here and 2 more electrons here. So we know both are non-metals. That means oxygen, oxygen, non-metal. They cannot give nor take. So what happens is, how many electrons do they share? So if they share one electron, it becomes 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That means they need 1 more electron. So they share 2 electrons each. So now it becomes 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, okay, first let's write the protons. 8 protons, 8. First orbit 1, 2, 1, 2, 3, 4, 5, 6. From this atom to they are sharing 2 electrons each. Let's count now. 1, 2, 3, 4, 5, 6, 7, 8 for this one. 1, 2, 3, 4, 5, 6, 7, 8. So how many electrons are they sharing? So this is oxygen. This is also oxygen atom. No ions are formed because there is no give and take. So one oxygen atom and the other oxygen atom share 2 electrons, forming a molecule of oxygen. So these two combine to form a molecule of oxygen. Since they are sharing 2 electrons each, this type of covalent bond is known as a double bond. So here they were sharing only 1 electron each, and here they are sharing 2 electrons each. We don't count all 4 for each. So they are this is sharing 1, 2. This is also sharing 1, 2. That is why we draw only 1, 2. Okay. So each atom is sharing 2 electrons. Hence a double bond is formed to form a molecule of oxygen. Now the third example, formation of nitrogen molecule. Nitrogen is also diatomic, N2. That means 2 atoms of nitrogen combine to form a molecule of nitrogen. Atomic number of nitrogen according to the periodic table is 7. We know atomic number equals to number of protons, which is equal to the number of electrons. So if atomic number is 7, number of protons is also 7, number of electrons is also 7. Now using the number of electrons, we write the electronic configuration. So nitrogen, number of electrons 7, first orbit 2, so 7 minus 2, how many left? 5. So 5 in the second orbit. Similarly with the second atom of nitrogen also 2 and 5. So this is one atom of nitrogen, this is the other atom of nitrogen. Number of protons 7, number of protons 7. So first orbit 2, 1, 2. Second orbit 1, 2, 3, 4, 5. Second one 1, 2, 1, 2, 3, 4, 5. So if 5 is there in the outermost orbit, how many do we need? 6, 7, 8. That means 3 electrons more, because the second orbit onwards we need 8 electrons, isn't it? So 5 are there. How many is required? 6, 7, 8. 3 electrons. So how many electrons do they share? 1, 2, 3. So they share 3 electrons each. So to make the atom stable, what do we have to do? There should be 8 electrons in the outermost orbit, except for hydrogen, where only 2 is required. So first atom, second atom, B equals to 7, B equals to 7, 1, 2, 1, 2, second one, so let's count now. 1, 2, 3, 4, 5, 6, 7, 8 for this one. 1, 2, 3, 4, 5, 6, 7, 8 for this one. So how many electrons are they sharing? 3 electrons each. So 2 atoms of nitrogen, by sharing 3 electrons each, form a molecule of nitrogen. And since they're sharing 3 electrons each, this type of covalent bond is known as triple bond. So covalent bond is formed between 2 nonmetals. In this type of bond, there is no give and take, so there is no formation of ions. The 2 nonmetals share electrons depending on the number of electrons that are required. The first example that we did was the formation of a hydrogen molecule. Hydrogen is diatomic, H2. That means 2 atoms of hydrogen are present. So H plus H will give you H2. Atomic number of hydrogen is 1. Periodic table, hydrogen is the first element, so the atomic number is 1. Atomic number equals to number of protons, which is equal to the number of electrons. So it's all 1. Using the number of electrons, we write the electronic configuration 1, 1. So the first orbit has 1 electron each. Now in the first orbit, how many electrons do we need? 2. So if they share the electrons, that means both will have 2 electrons each. Here see, so they are sharing the electrons. So this atom also will have how many electrons now? 1, 2. This atom will also have how many electrons? 1, 2. So 2 hydrogen atoms, by sharing 1 electron each, form a hydrogen molecule. And this type of bond is covalent bond is known as single bond. The next example we did was formation of an oxygen molecule. Oxygen is also diatomic, O2. That means how many atoms of oxygen are there? 2. So O plus O will give you O2. According to the periodic table, atomic number of oxygen is 8. We know atomic number equals to number of protons, which is equal to number of electrons. So all are 8. So using the number of electrons, we write the electronic configuration. First orbit 2. So 8 minus 2, how many left? 6. So 6 in the second orbit. So we draw the electron dot diagram. So how many more do they need? 2. This atom also requires 2 electrons to become 8. And this atom also requires 2 more electrons to be 8. So they share 2 electrons each. So see here, 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. So 2 oxygen atoms, by sharing 2 electrons each, form a molecule of oxygen. Since 2 electrons are being each atom is sharing 2 electrons, a double bond is formed. Similarly, formation of nitrogen molecule, diatomic N2, that means 2 atoms of nitrogen form a molecule of nitrogen. According to the periodic table, atomic number of nitrogen is 7. So all these also become 7. So number of electrons is 7. Electronic configuration first 2, 7. So since 7 is here, 7 minus 2 is 5. So the second orbit will have 5 electrons. Draw the electron dot diagram. Now this atom of nitrogen also requires 3 more electrons, and this atom of nitrogen also requires 3 more electrons to become 8. So they share 3 electrons each. So let's count 1, 2, 3, 4, 5, 6, 7, 8. This atom will have 8 electrons, and similarly this atom will also have 8 electrons. So 2 atoms of nitrogen, by sharing 3 electrons each, form a molecule of nitrogen. Since they are sharing 3 electrons each, this type of covalent bond. I hope everyone understood what was done today. Thank you. Bye-bye.